Alright, let's solve the following inequality. Negative 2 times x plus 4 times x minus 3 times x minus 2 squared is less than 0. Okay, so if we're trying to solve an inequality, let's first determine the critical points. And the critical points include x-intercepts, discontinuities, any kind of extrema. And really what we use the critical points for are basically to determine our intervals. Now in this case, I'm going to look at my x-intercepts. So the x-intercepts can be determined when you set this expression to equal 0. I'm going to call this expression f of x, right? If I let f of x equal 0, you can imagine that if any of these factors equal 0, 0 times the other factor will give you 0. So I'm going to let each factor equal 0. So I'm going to let x plus 4 equal 0. So if x is equal to negative 4, then you have an x-intercept. And you can do that for each of the other factors. X minus 3 is equal to 0. X is equal to 3, and also x will be equal to 2, right? So those are our x-intercepts, and after we have our x-intercepts, which include negative 4, 2, and 3, what you want to do here is design a number line to determine the intervals. So the critical points are used to determine intervals, and the space between the critical points is basically an interval. Now I'm going to show you that using a number line. So I'm going to just do that here. Okay, and let's say that this is 0. And because we're looking at values that are less than 0, this means that they are not inclusive of 0. So we're going to basically use non-inclusive points. So I'm going to use a non-colored in circle here. So this is negative 4. So it's not going to include negative 4 because then the whole expression itself will be equal to 0. This is negative 4. This is negative infinity. This is like 0. This is 2. And this is 3. Okay? And then this is positive infinity. And the intervals here are going to be in between the critical points. So I'm just going to design the intervals here. So this is basically one of the intervals, negative infinity and negative 4. So it's not inclusive. Infinity can't be inclusive anyways because there is no number infinity. It's a continuum. But it's not going to include negative 4 because this is basically going to give us 0 in the expression. Now, the other interval here is between negative 4 and 2. So in between the critical points, this is another interval that we're going to be looking at. We also have an interval between 2 and 3, and we also have an interval between 3 and positive infinity. And the rule of thumb is that you're always going to have one more extra interval than critical points, right? So now we have 4 intervals, and after you create your intervals, the third step here is designing a table of intervals to test which of these intervals, which values of x will cause the expression to be less than 0. So to do that, I'm just going to design a table of values of intervals. Okay, x belongs to, and then we're going to basically put those intervals in, so negative infinity, negative 4. So place the intervals on top here, negative 4 and 2. We'll also have 2 and 3, and we'll also have 3 and positive infinity. Okay, so after you put the intervals on top, on the top row, then what I'm going to do here is I'm going to put my factors on this column here. Okay, so my factors, and you do have to include the negative 2, so I'm just going to include it with negative 2 and x plus 4. And you can put this in any order because multiplication is commutative. What that means is 3 times 4 is the same as 4 times 3. You can basically switch around the order. The other factor here is x minus 3, and we also have x minus 2 squared. Okay. Collectively, I'm going to call this guy f of x, which we said that f of x is this combined expression here. And then we want to test the signs. Now within each interval, I'm going to find a certain value of x. So that's why I wrote down x belongs to each of these values within the interval. So between negative infinity and negative 4, I'm going to let x equal negative 5. If I let x equal negative 5, I'm going to apply this value to all of my factors in this column. So when x is equal to negative 5, we get negative 5 plus 4, which is negative 1, times negative 2, which is positive 2. So the sign here is positive. We just have to look at the sign. We don't have to calculate it. Negative 5 in here gives us negative 5 minus 3, which is negative 8, so that's a negative. negative 5 into this factor. Now this factor will always create positive outputs because of the fact that even if you have a negative squared, you always get positive. So I'm just going to write positive across the board. So we really only have to look at these two factors. And you don't actually have to write this in your interval table, but it's good to kind of understand it. And then between this interval, let's say x is equal to, okay, let's test out the interval between negative 4 and 2. So let's say x is equal to 0. So then this is going to basically be 0 plus 4, which is positive 4, times negative 2 is negative 8. 0 minus 3 is negative 3. And then two negatives and a positive give us a positive, right? So what you can do at the end of this is you can multiply all the factors to get the overall sign of f of x. So the positive times negative is going to give you a negative, right? And whenever you see a negative value for f of x, we know that this is less than 0. So this is one of our solutions, right? Here we have a positive value, so this tells us a positive value means it's greater or equal to 0. So this is not a solution. I should get rid of that arrow. Okay, it's not a solution. Between the interval of 2 and 3, I'm going to let x equal 2.5. If x is equal to 2.5, if 2.5 plus 4, which is like 6.5 times negative 2, you can understand that that's a negative value. 2.5 minus 3, that's a negative value. This guy will always be positive, so the two negatives will give you a positive, so this is a positive. So this is greater or equal to 0, right? And then between that, we'll also take a look at, negative, yeah, that's negative, sorry. Anyways, let's take a look at the last point here, so 3 and positive infinity, so last interval, x is equal to 4. So if I let x equal 4, then this is 8 times negative 2, which is negative 16, so this is negative. 4 minus 3, which is positive 1, and then this is negative. Right, so this is less than 0. So our two solutions here that are less than 0, where the inequality is less than 0 when it's negative, therefore x can belong to negative infinity and negative 4, but as well as 3 and positive infinity. So we use this symbol union to mean or, so it can be in this interval or this interval. Okay, and this is how we solve our inequality.